In this video, we're going to have a look at the proof of the next examinable theorem, which is Theorem 9. This theorem states that the angle between a tangent to a circle and a chord drawn from the point of contact is equal to an angle in the alternate segment. So this is our famous tan-chord theorem. Now we've been given that TB is a tangent, and you'll see in your notes that T has been forgotten, so let's just pop a T in there. TB is a tangent and O is the center of the circle. And we are in fact required to prove, at the end we want to have proven that this angle B1 is equal to that angle C1. We can't assume it, that's going to be our conclusion at the end. Okay, so let's take those out. Cool. So let's see how we go about doing this proof. Now, the first step in our proof, as with many of our other proofs, is to do a construction. So we are going to start by constructing, let me do that in green, constructing the diameter BK. So it's a line that passes straight through the center. So if I get that right, there we go, BK. And we are also joining C to K. So you see we're creating a triangle there. Cool. So we're done with our construction. Now, just scroll down a bit. Now we know based on that B1 plus B2 is 90 degrees. So this is 90 degrees. Remember from a previous theorem that the tangent is perpendicular to the radius. Now we also know that C1 and C2 adds up to 90 because of angle in a semicircle. So that is also 90 because of angle in a semicircle. Cool. But hang on a second. B2 is equal to C2. So let's have a look at that. B2, that's my B2, is equal to C2 because of angles in the same segment. We're going to be looking for that bow tie type shape. Let me actually highlight it for you so that it stands out. Here's your angles in the same segment. There you go. Okay, so that's your angles in the same segment. That's why B2 is equal to C2. Let me just take those out again so they don't get distracting. Cool. Alright, so now we know that B2 is equal to C2. Therefore, we can conclude that B1 is equal to C1. Because we've said here, B2 is equal to C2. So therefore, these guys, B1 and C1, must be equal for those equations to be true. Okay. And that is, in fact, exactly what we were trying to prove. So we've now proven B1 is equal to C1. Exactly what we wanted to prove. Now let's just recap what we did in this proof, because remember in an exam or a test, it's going to look a little bit different, it's going to be labeled a little bit differently. So let's just go through the chunks of this proof that we did. First we did our construction. We constructed the diameter and we joined C and K. We wanted to make that triangle. Then what we did was we had a look at our 90-degree angles. 90-degree angles. Where were they? But hang on a second, we had two other angles that were equal. Led us straight to our conclusion. Cool. Happy studying.